Orb Weaver webs engineering marvels of nature. The Orb Weaver spider's webs are truly a marvel of nature, aren't they? It's easy to appreciate their beauty, but what many don't realize is the sheer complexity involved in building one. Each strand isn't just randomly placed, it's strategically designed and meticulously constructed. The silk itself varies in strength and elasticity depending on its purpose. Some strands are incredibly tough for the radial lines that form the web's framework, while others, the spiral capture threads, are designed to be sticky and vibrate at a specific frequency when disturbed. This vibration alerts the spider to potential prey. Furthermore, orb weavers rebuild their webs almost every night, constantly repairing damage and optimizing its structure based on wind conditions and previous trapping success. It's an ongoing process of engineering and adaptation. It's easy to look at an orb weaver's web and think it's just a random tangle of silk, but that couldn't be further from the truth. These spiders are masterful architects, meticulously crafting their webs according to precise designs. Each strand isn't placed haphazardly, rather, they follow a detailed blueprint optimized for maximum prey capture. The arrangement of spirals, radial threads, even the spacing between them, is carefully calculated based on factors like wind patterns and common insect flight paths in the area. This inherent structural intelligence allows orb weavers to create incredibly efficient traps, turning their webs into remarkable feats of natural engineering. Before even starting on its iconic orb-shaped web, an orb weaver spider employs a clever technique to secure its masterpiece. It begins by releasing what we call bridge lines. These aren't part of the final web itself, but rather initial strands launched from surrounding plants, often hedges or trees. Think of them as tiny ropes, carefully shot out and sticking to surfaces like Velcro. They act as crucial anchors, providing a solid foundation for the entire web structure. You'll be amazed at how far these bridge lines can reach. They routinely span impressive distances across gardens, connecting seemingly disparate points in the landscape. These radial threads are truly remarkable. They're what give an orb web its characteristic wheel-like appearance. They extend outwards from the central bridge lines, acting like spokes on a bicycle wheel to create a strong and stable framework. Critically, these spokes aren't coated in sticky silk. This is deliberate. The spider needs to move around within its own creation without becoming hopelessly glued in place. This non-sticky design allows for quick repairs, efficient prey capture, and ultimately, the spider's survival. This is where the real artistry comes in. After establishing that initial framework of non-sticky threads, the orb weaver begins its intricate construction, a beautiful, spiraling masterpiece. It starts right at the center and slowly builds outwards, meticulously laying down concentric circles of silk. As it progresses, it systematically replaces those supporting scaffolding threads with this new spiral structure. Each strand is precisely placed, creating an incredibly even and stable design. And crucially, these final spiral threads are coated in tiny droplets of adhesive, a powerful glue that will ensure any unsuspecting insect becomes hopelessly trapped. It's truly fascinating how intelligent these spiders are when it comes to web construction. Orb weavers don't just spin a generic design, They actively adapt their webs based on the world around them. If the wind consistently blows from one direction, you'll often see the web subtly angled to minimize its impact. Similarly, if there's dense foliage nearby, the spider will adjust the spacing of the silk lines to avoid collisions and ensure prey can still reach it easily. This isn't a once-and-done process. Either they frequently rebuild their webs each night, constantly refining them for peak efficiency. It's an incredible example of how animals use environmental feedback to optimize their survival strategies. It's truly remarkable how orb weavers manage to capture prey consistently. The silk they produce isn't just sticky, it's a marvel of engineering in itself. Consider this: the web needs to withstand incredible forces, insects slamming into it at speed. That's why the silk is exceptionally strong and possesses amazing elasticity. This combination allows the web to stretch and absorb that impact, preventing it from ripping apart. It's essentially nature's way of creating a resilient shock absorber, showcasing principles we're only beginning to fully understand in modern materials science. The material's properties are finely tuned for this specific purpose, trapping food without self-destruction. Orb weavers are masters of detection thanks to their incredibly sensitive webs. Each strand acts like a tiny antenna, constantly picking up vibrations from even the slightest breeze. But it's not just random movement. They're listening for its specific patterns that signal prey. When an insect blunders into the sticky spiral of the web, the resulting vibration creates a unique frequency. The spider, positioned nearby, instantly recognizes this signature, differentiating it from wind or falling debris. It's an almost instantaneous response, allowing the orb weaver to swiftly rush out and subdue its meal before it can even struggle. Take a closer look at that distinctive head shape. It's truly remarkable, isn't it? It might seem almost skull-like, but this isn't just an aesthetic feature. It plays a crucial role in the orb weaver's incredible hunting abilities. The unique angles and contours of their cephalothorax are finely tuned to act as vibration detectors. Imagine them as miniature radar dishes, constantly scanning the environment for the faintest tremors caused by struggling insects. These vibrations travel through leaves, branches, and even the air itself, and the orb weaver's head is perfectly designed to pick up on them from surprising distances. This sensitivity allows them to pinpoint prey long before they even enter striking range, significantly boosting their hunting success rate. It's truly astonishing to consider just how intricate an orb weaver's web really is. It's far more than a simple sticky mess designed to catch unsuspecting insects. It represents millions of years of evolutionary refinement. The radial threads, forming the characteristic spokes of the orb, are incredibly strong and nearly invisible, built for resilience against wind and the weight of potential prey. Then there's the spiral, the capture spiral, which is coated in a glue-like substance that's remarkably effective at trapping insects. What's even more remarkable is that the spider doesn't just spin this web randomly. It carefully calculates angles, tensions, and silk properties to maximize its efficiency. They can often repair damage within minutes, demonstrating an instinctive understanding of structural integrity. It's a testament to nature's ingenuity, a beautiful example of how form perfectly follows function.